Okay, so what I'm going to do is I made this little video so that you can try and do these problems and hopefully listen to me if you have questions. If not, you can just mute me. And so we're starting with some chapter 17 practice problems. So the first problem we're going to deal with is dealing with left-handed people. And it's going to take up a couple slides, but I worked each one out. So what's going to happen is a problem's going to come up. And then what you're going to need to do is you're going to need to pause it when you're ready. So the first one is assume that 13% of people are left-handed. If we select 5 people at random, find the probability of each outcome below. There's 6 different probabilities we're going to do. We're going to do one at a time. The first one is the first lefty is the 5th person to be chosen. So pause the video, see if you can figure this out. All right, so the first thing you have to do is figure out that this is geometric because we're looking for the first success, and we know it's exact, so that's going to be the PDF. So when we use the geometric PDF, our probability goes first, and so that's the 0.13, and then our 5 is the 5th person, and so there's a probability of 0.0745. All right, same thing. Try the next one. There are some lefties among 5 people. So again, the first thing you have to do is figure out if it's geometric and or binomial. This is binomial because it is up to a certain amount, and since it's up to, it's going to be CDF. And again, it's binomial because it's saying that there's some. It's not saying just one. It's saying that there could be multiple of them. So we have an equation for binomial and geometric that goes up to, but we want 1 minus having no lefties so that we could see what happens with that. So we have the binomial, there's 5 and the 13%, and the chance of us picking none is 0.498. And so now we're going to do 1 minus that. And so that we know if we pick none, remember it's at least you always subtract from 1. All right, same problem again, another probability issue. This one's asking you the first lefty is the 2nd or 3rd person to be chosen. So what you should see is that it's geometric because it's exactly the 2nd or exactly the 3rd. But what's different about it is it has this or right here. And remember, or means that we're going to have to add. So we're going to have to find 2 geometric probabilities and add them together. So I need to find the one for the 2nd landing, the one where the 3rd person is chosen, and then we're going to add those 2 together because it's 2nd or 3rd to get a probability of 0.211497. All right, the next problem we have is there is exactly 3 lefties in the group. So take a minute, see if you can figure out if it's binomial geometric. It is binomial because it's exactly, and since it's exactly, we're going to do PDF. The binomial is going to be 5, 13%, and we're choosing 3, which gives us a 0.0166. Same question again, this time another probability, 1 more, or 2 more. There are at least 3 lefties in the group. So figure out if you think it's geometric or binomial, and remember that it says at least 3. So binomial is exact because we could have, and it's exact, we could have 3, we could have 4, or we could have 5. So this is like that previous problem where it could have been the 2nd or 3rd choice. So now what we're going to have to do is we're going to have to find the binomial for each one, and we're going to add them up. So the 3 lefties, the 4 lefties, and then the 5 lefties. To find out if there's at least 3, so 3, 4, 5, we're going to add those up. And I did not write what that sum is, but you guys can plug that in the calculator and find out what it is. All right, last one on this is that there are no more than 3 lefties in the group. So pause the video and see if you can figure out what that is. So again, binomial. Now it says no more than, so that's going to be our at most, and so that's our CDF. And so it's 0.9987. Okay, so now we're going to still deal with lefties, but now we're talking about right-hand people who have to sit in left-handed desks. And this is actually only one problem, but it takes a couple different steps. So it's going to be important for you to go back and see where the information came from or try it out on your own. Okay, so a lecture hall has 200 seats with folding armchairs, 30 of which are designed for left-handers. The average size of classes that meet there is 188, and we can assume that about 13% of the students are left-handed. What's the probability that a right-hand student in one of those classes is forced to use a lefty arm table? So the first thing we have to do is we have to find the probability that a right-handed student will have to use a left-handed desk. So thinking about that, we also need to determine if this is a Bernoulli trial. So let's do that first. Can it be considered a trial? Yes. How do you know it's a trial? Well, we know it's a trial because you have two options. You're either right-handed or you're not, or the desk is right-handed or not. The probability of right-handed is 0.87, which is assumed to be constant. It's not going to change. And then the population is infinite. Even though it does say that there's 200 seats and that there's 188 students, we know that the population of students around is infinite because it's also based on our 13% being infinite. Okay, so what type of model is this? And again, I'm go back to this question right up here where it says find the probability that a right-handed student will have to use a left-handed desk. So we're trying to find out how many times a right-handed student is going to have to use a left-handed desk. Okay, and so this is binomial, and it's going to be at most. The only thing is we have one that goes up to. So at most would be over something, but up to would be less than. So we're going to have to actually do 1 minus that binomial. So that way we can find what is over it, not under it. So we know there's 200 chairs available. But if we minus 30 chairs, that means there's only 170 chairs that are available for right-handed people. So we have 188 students. The probability of being right-handed is 0.87, and we want to sit in a right-handed chair, which is 170. So 93.9 or 0.939 percent of the time, or our probability, we would be sitting in a right-handed chair. So that means the rest of the time, 0.061% of the time, we would not be sitting in a right-handed chair. We'd be stuck in the left-handed chair, which would be horrible. Okay, so what this just does is it just says how many times will a right-handed person have to sit in a chair. Well, there's still another part. Oops, I forgot to read the summary. According to the binomial model, the probability that a right-handed student has to use a left-handed desk is approximately 0.061. And again, that's just the first part. Now what we have to do is we have to find out, same question, the probability that there will be at least 171 righties in the class. Because if that number changes, then our other numbers will change. So we have to find out the probability of this also. Okay, so setting up a normal model from the binomial probability model and the mean standard deviation. So we need to use our formulas. And so the expected value on the binomial is n times p, where n is the number of trials and p is the probability. So find the mean is n times p. So there's 188 chairs, or 188 students. 87% of the time they are righties, so we are expected to have 163.56 righties. We need to do the same thing for the standard deviation, and the formula for the standard deviation was the square root of n times p times q. So it's the square root, and I didn't have a tool that would draw the line above, so it looks funky, but it works. So it's 188 times 0.87 times 0.13, which will give us 4.61 righties. So what's going on now is same idea. We have 200 chairs available, but we're taking away those 30 chairs, so there's 170 lefty chairs. And we're looking for the probability that a right-handed student will have to sit in a left-handed desk. So that means that there's going to have to be at least 171. So it's the normal PDF. Our lower number is 171. Our higher number is 188 because that's the max students. We found our mean, and we found our standard deviation. So according to this, the normal model, the probability that there are at least 171 righties in the class of 188 is approximately 0.0533. So go back over this if you didn't understand it. Try and watch it again or try it again and look at the formulas. It might help to actually try and work them out, plug them in your calculator to see if they match up.